Hi, so glad you're here. I knew you'd make it because you're my good student. All right, we're going to look at 3.4, solving proportions. So let's just jump in. You got your notes in front of you and let's do this. So before we solve proportions, let's find out what a proportion is. So a proportion is going to be an equation. Where's my pen? Oh, there it is. That sets two ratios equal to one another. Now, we're going to use this little shortcut to solve this proportion, and it's a method that we call cross products. And you've probably done it before, but we'll go through it again. So the numerator of one side is multiplied by the denominator of the other side, and then set equal to the product of the other numerator and denominator. So let me show you what we mean by that. So usually there's three values that are given and only one is missing. So the one that's missing is x, and we want to solve for that. So we're going to multiply that numerator by the denominator across the equal sign. So 11 times x, which will give us 11x. We set that equal to the product of 8 times 66, which is 528. So then I'll divide by 11. That cancels out and gives me my x. And 528 divided by 11 is 48. So I want you at this time to try these two on your own. Pause the video, and when you've solved them on your paper, go ahead and hit play again and see the answers. Pause now. So now here's the answers. Check your work and see if there's, if you did it all right, or if there's some questions, or maybe you can see find any errors. But if you did it all great, wonderful. If you had a little problem with it, make sure that you come see me and we'll work on getting that finished for you. So we can step up the difficulty level of this because sometimes the proportions are going to have more than just one variable as part of it's either the numerator or the denominator. And the process when we use those cross products is still used, but in addition, we're going to use the distributive property. So let's take a look at this example. So when I take cross products here, the 80 is being multiplied to the x plus 3, and the other one is 64 times 10. So I'm going to use distributive property to distribute the 80 to the x and the 3. So 80 times x is 80x, and 80 times 3 is 240. And on this side, we'll multiply 64 times 10, and that gives me 640. So now I solve it just the way that we would solve any other linear equation. We're going to subtract 240 from each side of the equation. And we get 80 is equal to 400, or 80x, I'm sorry, 80x is equal to 400. So then I'll divide by 80. And the 80s cancel. I get x equals, and 40 divided by 80 is 5. And once again, you have the opportunity to try one on your own. So pause the video once again and try this out and see how you do. So there's the answer that you got. Pause this if you need to look at the steps and check this against your work. So we can also apply this proportion to geometry things. So we use them to compare figures, in this case triangles, that are similar. There it is, similar. Meaning that their sides are going to be proportional. So take a look at these two triangles and notice that the two sides of the first triangle are in the same position as the two sides of the second, and we're going to set that up. So that's going to be helping for us. So I'm going to compare the short leg to the long leg of each of the triangles. So the short leg of my first triangle, this will be my first one, is the short leg is x compared to 12. And on the second triangle, the short leg is 5 and the long leg is, oops, and I should have wrote long, sorry, long, short to long. And then I can use the proportions. So I'm going to do cross products. X times 6 is 6x, and 12 times 5 is 60, and I'll divide by 6, and x is equal to 10. So now we have our application problems. So let's read this. You're driving from New York to Phoenix, a trip of 2,450 miles. You begin the trip with a full tank of gas, and after traveling 424, you refill the tank for $58. Assuming those gas prices will be the same for the duration of your trip, how much should you plan on gasoline for the entire trip? So what we're going to do is compare miles to the price of our gas. So that one leg of the trip, we were going 424 miles and we used $58. We want to know how much will we spend if we're going 2,450 miles. So the numbers are bigger, but we're doing it the same way. I'm going to do cross products. I'll have 424x is equal to 2,450 times 58, the other product. So I get 424x is equal, and when I multiply that, I get 142,100. And I'll divide that by 424. And the price is going to be my x, and I'm going to round that. I believe it's $335 and 14 cents.